Welcome to 2014, question C2. This is a structural forms question. The graphic on the right shows the clubhouse of the Dubai Creek Golf and Yacht Club. The design of the building was inspired by the sails of a ship. Okay, so kind of a complex roof structure there. Projections of the structure are shown here in C2. An isometric view is also given. So we've got our isometric view. Curved surface is produced by translating and generating parabola ABC in a vertical position along parabola EBD. Okay, so we've got parabola ABC here, so ABC. Let's highlight that. There's our parabola ABC. And it's translating along E, B, and down to D. Okay, so that's an identical parabola at each one of at every vertical section we take there. Okay, and it's also worth knowing they've given us 1, 2, 3, 4, 5 vertical sections there. So that might be how many is required in the marking scheme. Okay, so the generating parabola ABC is represented by a dotted line in the outline of the end view. So we've got our dashed line here, and they've given us the overall height and width of that rectangle that's going to be fitting into. B is the vertex of both parabola ABC and parabola EBD. So a vertex here and a vertex here. So this is also a parabola we're going to need to construct. We have the width, or half the width of the rectangle it's going to fit into, and we have the height. So first off, they want us to draw the given elevation of the structure. So they want us to draw this. So as I said, that's a parabola, or a half parabola. We can find the other side of it. Our scale is 1:100, so 15 meters is going to be 150 millimeters. That'll be 60, 120, 75, and so you can write in those measurements. So I'm going to start off here with my width of 15. I'm just trying to space this out. Okay, so 15 more. Okay, and I'm going to also have 16 on this side. So the rectangle that this is going to fit into is going to be 75 high. That's where it's going to finish. That's where E is. Okay, so my parabola is going to go from B down to D. So we're going to divide this up into equal parts. Might as well do 5 equal parts. 1, 2, 3. So 1, 2, 3, 4, 5. It's kind of giving us that indication. Okay, which is an easy thing because our 150 is going to divide by 5, and our 75 will also, will it? $75 divided by 5. Yeah, 15. Okay, so that will save me a little bit of trouble. I won't have to do my dividing lines into 5 equal parts construction. So let's marking off our distances: 20, 90, 60, 30. So vertical members, or vertical sections, can be in those positions. Okay, let's have that 75, right up in 15, okay, so those sides are going to join up to my vertex. It's always handy that if we can do this without having to do our dividing lines into equal parts construction, it'll save us time. So we've got point, 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 putting those in the wrong positions. Okay, so here is my curve. Okay, and then we're just going to project across using axial symmetry. Okay, so point to the compass, set to, which is 30 actually, so that'll find me a new point, and then this is actually set to 60, which actually will be in line with that. So that's making life very easy for me, because that's 60, and this is also 60. Okay. So that has found me point E, which I can now join back down here, and close there. Okay, so we've got C, A, B, down to D, and I've got the location of those vertical sections, which will be handy later. So that's my elevation. Draw the end view of the generating parabola ABC. So we're going to draw our end view here over to the right hand side. We'll come over just a little bit, 20, doesn't really matter, and we know it is 12 meters, which is 120. Okay, and half of that then is going to be to the position of B and B. That's there. So this is the rectangle that it will fit into. I've got A, B, C. Okay, so I know I can divide up this side into 12 equal parts, or into 5 equal parts. So let's do that. 45, 30, 15. Okay, and 5 into 60 actually goes 12 times, so I can do that too. 12, 24, 36, and 45. Okay, so I've got my construction lines parallel to the axis. I can join these ones along the side back up to the vertex. So at the moment, quite simple. This is almost junior cert level stuff. Let's try a parabola. We've got 1, 2, 3, 4 points. Okay, and I'll use axial symmetry just to project that across to the opposite side. So it's a point. Point. So axial symmetry, just speeding things along rather than the full construction on the opposite side. I'll just draw this correctly. Okay, draw a dashed line just to communicate that. Okay, so that is the end view of that generating parabola. Now we want to project the plan of the structure. So let's project down the points we can find to begin with. So project down vertically first of all, and now let's go 45 degrees to project from end elevation to plan. Okay, so we've got A, B, C, E, and here's point D. So, as I said earlier, at each one of these sections, an infinite amount of times, that A, B, C, okay, is traveling along here. Okay, so if I was to take a section here at this part, okay, that's an identical parabola. Okay, so we're basically getting small, but it's basically getting smaller and smaller and smaller. And those 5 vertical sections are kind of guides that we're going to use. So if that's the original height, okay, it's now going to get a little bit smaller, right? So the height is going to change from its original height to maybe something a little bit smaller. So the width then of that is going to change on our parabola. Okay, so we're going to take the height at this section, in this position, and I'm going to step it down from B. Okay, I'll just take a little slice across. So this is going to be the width of the parabola at that point. So we're going to project that down. Actually, do it a little bit quicker. I'm actually going to take that distance on my compass. Okay, I'll project down the position of that width, or of that section. So that distance now I can take and show here. Here. Okay, I'm actually going to project on all of these what I can. So next up we have this height. So step that down. That's the new height. So I can take that distance, okay, which is identical on both sides, and corresponding bit there to there. Okay, we're on to the next one. So that's my height. Step down from B and across. So that is our width. Okay, and finally we're on to the last point here. So that distance, that height, step it down from B again. So that distance out then, it's changed all the time. So I can draw my freehand curve. C back to A. Okay, and then that's the point. We still have this side to do. So for that part, okay, it's going to be narrower. So let me just show here. This is going to be getting narrower and narrower and narrower, right? The heights are actually going to be different to the ones on this side, okay, because as you can see it's cut short. So I'm going to take, just one, no, I'll take a couple of sections here. If I take a section there, that height will be the height that I need to step off, because that's the height of the helix, or the parabola at that point. So let's come out here, and I'm going to split that 60 up maybe into 20-20. So this height from there to there, okay, is the height of the parabola I'm doing it at this point. So it will come down from B, swing an arc, project that out. It's pretty close to the same size as something I've done already. We'll get that distance then. That's the width of that parabola at that point. And we can swing an arc here and here. Okay, we'll do the same thing then at this point. The height of my parabola here. Step it off. And that width there will be the height of the parabola at that point. Okay, so let's draw in our curve. Okay, to E, and always looking at the point we're traveling to, just get a nice gradual curve. So that's our parabola in that position. Okay, so that's the plan of our structure completed there also. Lastly then, okay, everything there? Yeah. Lastly then, determine the true shape of surface EAC, or AEC, so AEC. Here's AEC. Okay, so that surface there. So we have an edge view of AEC, which is great. So I've got two options. I can either take an auxiliary plan, because I'm projecting from elevation, looking perpendicular to that, so x1, y1, project down here, and I can get my distances from my x, y down. I'm kind of tight on space here, and there's no space above either. So what we can also do is we can actually rotate that surface down. Okay, I'm going to use the points as well that I found. So I've got these points, which here are corresponding points, and that will make life a little bit easier for me. So rotate about line AC down, so it's resting on the horizontal plane. Okay, and we'll project that down, and E is going to stay in that position, so E will be there. Okay, and we'll rotate these other points down. There, rotate it down. That's where they hit the horizontal plane. So we follow there, down to here. And there. Okay, and there. Rotates to that point. That rotates to that point. Okay, so I've got the distance to travel there. If I want, I might even, no, that's probably enough. Should be able to draw it freehand. Yeah, so that's rotated down into that position. Okay. And we won't have an edge there just to show it. Okay, so that is the true shape of surface AEC. Okay, so include there, just to show the final solution. There we have it. So the key thing is that bit, understanding that vertical sections is just decreasing the height of our parabola and finding the width then of that corresponding shorter parabola.